So guys, myself Shovik Goswami Chaudhary from NK Institute. So today we will discuss the performance of line. Performance of line is a chapter of power system. Okay. So power system is a subject of electrical engineering BTech syllabus. Okay. So today we will discuss one of the important chapter of power system, which is performance of line. One, performance of line. So guys, this is very important thing. As we know that this is very important for government job, GATE purpose, and that is for semester purpose also. So we will discuss the basic concept. In this video, we will discuss about the basic concept of the performance of line. So first, I want to give you some brief idea. Okay. So the brief idea, that is the most important thing actually. Okay. So some people actually mistakenly just taken that the length of the line is that and the length of the short medium line is that. So which is true, which is exact, I want to discuss you today. Okay. So the thing is, to start with the performance of lines, I need to go with the basic thing. What is the length of the line? Length of lines. So according to length of line, we can divide it into three parts. Okay. What are the three parts? So guys, the three parts are short line, medium line, and long line. Okay. So the most important thing is we need to know which is short line, which is medium line, and which is long line as well. So in order to categorize each of them, we need to understand the length of each parameters. So what is the length of the short line? So if the length of any transmission line, any overhead line is less than 80 kilometers, then it will definitely comes under short line. Okay. Now we will reflect the light on this medium line. What is medium line? Medium line falls between, say L is the length of the medium line. So medium line falls between 80 kilometer to 240 kilometer. Okay. One more important thing is that, guy, in short line and in medium line, we will consider in our later part of analysis of the performance of line, we will consider these two lines parameters as a lumped parameter. I will throw light on the lumped parameter in this video later. Okay. So one remaining thing is long line. So what is the length of the long line? As you all know that medium line falls between 80 to 240. So something greater than 240 will becomes under long line. Okay. So guys, that is the basic concept of the length of lines. Okay. So now I will discuss you each one of them. Okay. Short line, medium line, and long line. So first we consider the short line. Okay. So in order to explain short line thoroughly, we need to consider a circuit. Okay. So what is the basic circuit? Say I am just sketching a circuit. That is Z. That means is impedance, and that is admittance. And this is the simple circuit, very simple. This is the sending end voltage, and this is the receiving end voltage. So this is the basic circuit configuration of the short line. So now guys, if the current flowing through these is IZ and current flowing through these is IY, and this is something different, some ID. Okay. So guys, let me tell you that this kind of capacitance, this is admittance actually. So this admittance is this admittance has very much less effect, okay, than the impedance portion. the impedance drop will be higher. So the current drawing through the source end will be greater than this current channelized through the shunt branch. So guys, I'm telling you that Iz is greater than Iy. So why so? So for capacitance it is Xc, we know. Okay. So I is equal to V by Xc. Okay. So what is Xc? What is Xc? We know I is equal to V by Xc is equal to 1 by j omega c. So if I just write it j omega c into V, okay, this is the shunt current. I am just expressing it as Iy. This is a shunt current. As you know, this is a shunt current. The current flowing through the capacitance formed between the live line and the ground line. Okay, so this is the shunt current. So I am telling you that this current is negligible. Why? See, this capacitance is very less. So that's why it's very less. Nothing else. It's so simple. So capacitance is very less means the distance between them is very small. So that's why capacitance effect is small, and that's why has poor effect on that circuit. So that's why we just neglect. This shunt portion. Guys, I think you're clear with that concept. So now let me proceed with the parameter calculation. So in order to calculate the parameters, okay, let me reconstruct the circuit. The circuit will look like that. This is sending in voltage and this is receiving end voltage. Okay, this is say Iz. Sorry, this is I am just denoting this sending end current, and this is the receiving end current. That's all, nothing else. So so in order to explain these short line parameters, okay, we need to first concentrate on the ABCD parameter. ABCD parameter. You guys heard about that? ABCD parameters? May not be heard about that. I'm just explaining in short. Okay, what is ABCD parameter? So in our two-port networks, suppose it is the impedance, okay, and it is the sending end voltage, and it is the receiving end voltage. Okay, this is the sending end current. This is the receiving end current. So what we need to do? We need to just do one simple matrix. Okay, we need to memorize one simple circuit which is like that. Vs Is is equal to ABCD VR. Guys, from this circuit we have deduced that. Okay, so I am just not going to that path. Okay, so that will be the big longer process. Okay, so that is not concerning over here. So we will just keep light on that fact, that is we need to memorize this equation very carefully. So what will it give? It will give Vs is equal to AVR plus BIR. Is equal to CVR plus DIR. Simple equation, guys. Simple matrix and simple equation. So let us consider this circuit. Okay. So guys, when we consider this circuit, what will be our KVL equation? The KVL equation will be like that. Vs is equal to ISZ plus VR. Okay, guys, the interesting fact is that you know that it's a series circuit, so the current will be same, Is and IR will be same. Okay, so I am putting just IR over here. Okay, I'm just putting IR over here. Okay, instead of Is. Why so? I will tell you definitely. And if we put the KCL over this node, we know that Is is equal to IR. So guys, the fun is here. If we denote this as a equation 1 and this as a equation 2, And now what we have to do, we have to just compare these two equations with these two equations. Nothing else. It's so easy. So so in order to doing so, we just reconstruct this equation as a Vs is equal to Is. I'm just cleaning this part and just showing you how it look like. So Vs, after reconstructing, Vs is equal to Vr is equal to IRZ, and the second equation is 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 equal to Ir. So guys, now we have to compare this equation with this equation, nothing else. So if we just want to compare with that, what we need to do? We just need to do the comparison of the coefficient. So what is the coefficient over here and what is the coefficient over here? So A is the coefficient in this equation and 1 is coefficient in this equation. So the value of A will be 1. Next, if we compare IR with IR is same. So the coefficient B over here and Z is here. So by comparing, we get B is equal to Z. And also by comparing this Is equal to IR, look carefully, just this portion is 0 for this case. Okay, so we can easily conclude that C is equal to 0. So if we just take this coefficient, the coefficient D is equal to 1, as there is a 1 and there is D. So D must be equal to 1. Okay. So in this process, we are just getting this type of parameters of short line. That's all. Nothing you need to do, nothing you need to do heavy work. Okay. You just need to go through this video, go through this process. You just write in your copy and it will memorize you, but it will memorize you forever. So now we want to, now I am to tell you some important thing, that is voltage regulation. So guys, you guys may have wondered that why I'm just telling this topic voltage regulation after the short transmission line. So the thing is that voltage regulation is very much related to that. Okay, so that's why I'm just telling you. Okay, one thing I skipped. Sorry, the thing is that the ultimate equation for short line will looks like that. Vs Is is equal to what we have got from that. A is equal to 1. Okay. B is equal to Z. C is equal to 0 and D is equal to 1. So we just put the values 1, Z, 0, 1 and accordingly VR and IR. So that's all of the short line. So now we just proceed with the voltage regulation. Voltage regulation means voltage percentage regulation. Obviously the regulation will be in percentage regulation. So what is regulation, guys? The regulation is, see this is the basic circuit. This is the basic circuit, okay? I'm just considering this basic circuit. Okay. Okay. So I'm supposed to get the voltage of 100 volt at the receiving end, but I'm not getting that voltage due to some drop, due to some voltage drop, and due to some any other reason, any kind of drop. It may be like some drop, negligible drop, maybe negligible, but it's a drop. So I'm not getting this value. I'm getting something less than that. That is 80 volt. So I'm just not getting this voltage, 100 voltage, what I am supposed to have. So the thing is that I'm getting the value less than that. Okay. So voltage regulation, percentage regulation defines that how much voltage is differs from which value I am supposed to get at the receiving end by that voltage, by that receiving voltage. Okay. So if we formulate that, if I am discussing about the voltage regulation, so what is voltage regulation? So voltage regulation is like that. Suppose at receiving end I am supposed to get the 100 volt of voltage, okay, but I am not receiving that amount of voltage. I am just receiving something less of that, okay. So why so? It is because I am just connecting some load into that, okay. Okay, so it's consuming some power, okay. So it's definitely the voltage drop will be there. So what will happen? We will not get that value of that voltage, 100 volt voltage at the receiving end at all time when we connect the load. So the thing is that, so if we just formulate the percentage voltage regulation, okay, I'm just denoting as the percentage VR, okay. So what will it become? So it will become, guys, as you can see, that it is the change of no load voltage from full load voltage divided by full load voltage. So what is that? What is that? Let me explain that expression. So what is the expression means? The expression means that the voltage at full load is changing from voltage at no load. How much it differs? It's a ratio, okay. So how much the full load voltage is differ from the no load voltage? As you guys know that the no load voltage is always greater than the full load voltage. So as because the some load is connected to there, so the no load voltage is always greater. So that's why the full load voltage is differ from that, and by what amount is differs, that is that amounts to voltage regulation. If we just multiply it by 100, then it will give the percentage voltage regulation. So guys, in this video I'm just giving you the idea of short line, after that voltage regulation, and some basic part of the performance of line, like the lumped parameter, distributed parameter, okay. So in next video I will discuss you the medium short line and the long line and many other things about the performance of lines. So in this video is for today it's over. So guys, please try to understand by watching this video, and just keep a copy side and just write in your copy in order to memorize that formula. This formula is so easy, not so difficult. So guys, if you like the video, please hit a like and please subscribe and share. So that's all. Thank you.